So how'd everybody do with the Sigma Unknown? So hopefully everybody did a good job with those. Again, I'll be around all day tomorrow if you have any questions or need any help or anything like that. So feel free to reach out to me. So with that in mind, let's jump in and talk about proportions. So again, everything about hypothesis testing is exactly the same. Basically, the setup's kind of the same. The only difference is just what things look like and stuff. So in this case, I was in a Halloweeny mood when I was making all my problems here. So again, since Halloween just occurred, I thought I'd have you guys test this claim. So I claim that students who eat orange M&Ms after Halloween will earn greater than a 90% in their math class. So everybody starts stocking up on orange M&Ms before they're all gone. So I surveyed our 24 students and found that 22 of them had A's. Can I conclude that orange M&Ms are the secret to earning an A in math? So I think probably so. I think that's very possible. So we'll see. All right, so again, let's write down what we know. So since this is a probability problem, we're going to know a little different stuff than we would for a mean. So again, we know our N is 24. Let's see, our X was 22 in this case. And in this case, remember, we have to actually calculate our P hat, which is going to be 22 divided by 24, or 11 over 12, or, oh, I forgot to bring my other calculator. Let me pull it up real quick here. So 0.917, let's say. 0.917. And then finally, again, we don't know alpha, so it looks like our alpha is just going to be 0.05. And so again, it's time to actually write down our claim, state the hypothesis. So we're going to get our H naught and our H1. Now be careful here, because up to this point, we've always been dealing with the mean, so we've always had a mu, but in this case, since we're dealing with the population proportion, we want to use regular P. So the claim was that I think that people that eat orange M&Ms are going to get a score greater than 90. So that's going to be our P is greater than 0.90. And our H naught then would be P is less than or equal to 0.90. All right. And so again, same thing down below. We've got our little chart and stuff like that. And so, but this is a one-tailed test because we've got greater than. So that means this shaded area over here is going to be our 0.05. So if we figure out where this guy would actually live, like figure out what the z-score would be, we could do our inverse norm just to get a rough idea of where we would stand with this. So if I do second vars inverse norm 0.95 comma, let's see, so I'm just going to do 0 and 1. So 1.64 looks like where this guy would live. So that's going to be the kind of the magic z-score we're looking for. So anything bigger than 1.64 tells us that we're going to be in that blue area, which means that we're going to be able to reject H naught. So let's go ahead and calculate our test statistic in this case. So remember, the test statistic in this case is a little bit, I forgot I need my Q hat up here. So I forgot that. So let's write down Q hat. And so remember, that's the same thing as 1 minus P hat in this case. So we're going to get 380 in this case. So that's our Q hat for this guy. And so our test statistic for probability is a little bit messier. So it's going to be the P hat minus P, and then divided by our square root. But if you remember, our square root is like, the equivalent of the standard deviation is P hat times Q hat, all divided by N, but the square root of the whole thing in this case. So in this case, we've got our P hat was 0.917 minus 0.9 all over 0.917 times 0.083, all divided by 24 in this case. So let's hope I remember all this stuff as I'm trying to type it in. Otherwise, I'll go bounce back and forth. So we got 0.917 minus 0.9 gives us that, divided by the square root of 0.917 times 0.083 divided by 24. All right, I think that looks right. So let's see what we get here. So that gives us 0.302, 0.302 in this case as our test statistic. So again, unless I've screwed something up, which is always possible. And so remember, for right now, our P90 would be, these are like z-scores we're looking at, so that would be 0. So 0.302 looks like it should fall kind of in this range on our number, or our normal curve. So if that's the case, it kind of looks like that this is going to be a fail to reject, that this isn't going to be the magic pill to get an A in math, which I'm a little disappointed in, so if that's really the case. So let's test it out just to see, so because again, I'm still holding out hope that this actually works, so we'll find out. So now we want to calculate the p-value that corresponds to this area. So again, since it's an upper one, we're going to do our normal CDF. And then we're going to do, now this one, let's see, because we don't have a standard deviation. So I think this one we're actually going to have to use the standard normal curve to actually calculate this guy. So this one, I guess it's good we did the test statistic on. So we could have actually done this with all of them, but if you remember, the normal curve requires you to have a standard deviation. And so, oh, well, I guess we could put this in. Well, I'm going to try this 2 different ways and see. Make sure I get this, see if I get this right or not. Hold on. So you could always do the normal curve on this guy if you wanted. So like in this case, I could do 0.302, comma 100,000, and then comma 0, comma 1. So kind of use our standard normal curve. But I'm going to try this and see, because I think this will work too. But I could be dead wrong, so we'll find out here in a second. So 0.917, comma 100,000. So 0.9, comma, and then the square root of that 0.917 times 0.083, all divided by 24. So knock on wood, I'm going to get the same answer for both of these guys. So if not, I know the top one will work, but I think it should be true for both of them. So let's find out here real quick. So I don't mind embarrassing myself in front of you guys. So, all right, so let's do the first one. So second bars, normal CDF, 0.302, comma, 100,000, comma, 0, comma, 1. And so again, so we've got 0.381%. Which is much greater than 0.05. But let me check this other one, because I have a feeling that this is going to work too. So let's check it out just to see. So in this case, we've got normal, second bars, normal CDF, 0.917, comma, 100,000, comma, 0.9, comma, square root of 0.917, oops, any parentheses around it, 0.917 times 0.083 divided by 24. Look at that. So it's off by a little bit, but then again, I rounded some of these numbers, so that's why it's off by a little bit, because it's not exactly 0.917, but it's basically the same. So you can do these either way. So you could do the standard normal, or you can use the kind of the mean standard deviation version. So in this case, so it's good to know I didn't screw up in front of you guys too bad. But either way, they're both greater than our alpha level of 0.05. So in this case, we're going to fail to reject H naught. There isn't sufficient evidence to prove that eating orange M&Ms after Halloween will give you an A in math. I'm very disappointed. I was really rooting for you guys too. I was hoping that this would be it, so that you could just stop studying, just start loading up on orange M&Ms, and you guys would be totally good. So it looks like you're gonna have to actually study at this point. So sorry, I tried, but the stats are in. The stats have proven that this just isn't gonna work. So too bad. Sorry. All right, so with that in mind, here's a couple more practice problems for you guys to work on. So we got practice 1, practice 2, practice 3. And so work on those, guys. And then when you're done, come on back. I've got one more little surprise video for you guys, and then we'll be done for the day.